Today, we're going to be looking at addition and subtraction. I know you've seen these concepts before, but we're going to try and look at them from a slightly different way today. I want to start by talking about the word identity. In mathematics, it has sort of a special meaning, and it kind of means equality, right? Like if two things are equal, they are identical, right? So that's sort of what we should be understanding this word identity to mean. For example, if I write down something like this, I could say A equals B, or A is identical to B, or like A and B are the same, right? So these are sort of a few different ways to describe the same concept. So if this is true, and then I give you an additional piece of information, I tell you that A is equal to 3, well, then we also know that B must also be equal to 3 because A and B are identical, right? Okay, so that's the first word we want to talk about today. The next concept I want to talk about is the additive identity. So what does this mean? Well, here's an example. Let's say I have a number, let's say 5. I should be able to add something to this number 5, and I will get the identical number right back. I will get the number 5 again. So what can I add to 5 to yield 5? Well, it must be the number 0. Right? The number 0. If I add 0 to 5, I'm just going to get 5 again. And this works for pretty much any real number. For example, what if I have the number negative pi over 2? What can I add to this in order to give me that same original number back? Well, I can add the number 0, okay? Because the number 0 is what we call the additive identity. So here's sort of the idea. With an additive identity, it's going to be something where adding it does not change the original value, right? And in particular, 0 is the additive identity. Whenever you add 0, you do not change the value. You get the same value back. So in general, we can say that any number A plus 0 will just equal A again. Okay, so that's the idea of an additive identity. When we come to other types of operations, we will find different types of identities. But for addition, the identity is 0. Next, I want to talk about negative numbers. And this is actually closely related with addition, surprisingly. The idea is, let's say I start with something like 5 is equal to 5. Okay, so that's great. That's true. These are identical numbers. They're the same. 5 is equal to 5. What can I do? Well, I could, if I wanted to, I could subtract 5 from both sides, couldn't I? So if I was to subtract 5 from both sides, what would I get? Well, there's a few different ways you could write this, but what I'm going to write is I'm going to write this as 5 plus negative 5 on the left-hand side, right? That's what this equals. This is the same as 5 plus negative 5. And then on the right-hand side, well, 5 minus 5, I'm going to say that's equal to 0, right? So 0, the additive identity. So what this is telling us is that if you have some number and you add the negative version of it to that number, you will get 0. You will get the additive identity. Let me try one other example here. Let's say we have the number negative 6, right? That is equal to negative 6. Okay, now what could I do to both sides? Well, I could add 6 to both sides, right? I could add 6 to both sides just like that. And if I was to do that, on the left-hand side, I could write this down as negative 6 plus positive 6 equals, in this case, 0, the additive identity. So once again, we have the same thing happening. We have a number, and then we're going to add its negative, and that is going to give us the additive identity 0. And so that is what negative numbers are sort of defined as. It's when you take a value and you add its negative, then you're going to get the additive identity, which is 0. Okay, so it's a funny way of describing negative numbers, but it's a more technically correct way of doing that. So in general, any number A plus its negative will equal the additive identity, which is 0. And this is how we get negative numbers to start with. Okay, now I'm going to talk about the concept of an inverse. An inverse is something that undoes some original operation. And in math, we're going to find this in a lot of different places. Let me try and give you an example of what this is talking about. So let's say we have these two crafting recipes, right? If you look at this first one, what are we doing? Well, we're going to take 9 of these iron ingots and we're going to combine them together to get one single iron block, right? So that's an operation. This operation does that. Well, if we wanted to undo that, what would we do? We'd take this iron block and we'd take it apart and break it back into 9 iron ingots. So these are inverses, okay? These are inverse operations of each other, right? This undoes this and vice versa, right? Taking the iron block and breaking it into 9 iron ingots, it undoes this original operation. So this is the concept of an inverse, and we're going to apply this to math in a lot of different ways. To start out, we're going to try and think about what is the inverse of addition. What undoes addition? Well, subtraction does, right? Subtraction is the inverse operation of addition. Let me give you an example. Let's say we start out with some number x and we add, whatever we want, 5 to it. And after that, we're going to get a result. We'll call that y. Okay, so this is the first operation. We start with x, we add 5 to it, we get y. Now, what happens if we now start with y and we want to get the original amount x back? We want to undo the original operation. What do we have to do? Well, we're going to have to subtract 5, won't we, right? So y minus 5 must get us x back. And so what we're seeing is that this subtraction is undoing the addition, right? Subtracting that 5 undoes the original operation when you add 5 to x. So this is how we can understand subtraction and addition sort of as inverses of each other. One operation can undo the other. But this leads me to an interesting question. Does subtraction really exist? I know it sounds kind of funny because I just described, what subtraction is, and, it's a button on your calculator, you can press it, so of course subtraction exists. But if you think about it, what are we really doing when we do subtraction? Let me give you an example here. What if you have, let's say 6 minus 2, I guess that'll equal 4, okay? So we can think about what's happening here as saying, well, let's say I have 6 apples, and then I take away 2 of them, I'm gonna have 4 apples remaining, right? So we can understand subtraction as like removing something from the original amount. But what I'm claiming is there's a better way to think about subtraction than this. I'm saying we should think about subtraction as the addition of a negative number. What I mean is you could take 6 and you could add negative 2 to that, and then you would get 4, right? So you can see that this equation and this equation, they're actually the same, aren't they, right? They're mathematically equivalent, but conceptually it's a little bit different. Here, we're actually thinking about adding a negative number, where reconceptualizing subtraction is actually a kind of addition. And I'm going to say, this is my claim, that this is a useful way of thinking about subtraction. Okay, so I want you to try and think of subtraction as the addition of a negative, where any a minus b is actually in your mind, think of it as some a plus a negative b, okay? That's going to help us out. Let's take a look why this helps us. So in a previous lesson, we looked at the commutative and associative properties when you're adding and multiplying real numbers. I want to apply those concepts to subtraction here. Okay, so let's take a look at the addition part first. So here what we have is we've got a 4 plus 3, and the commutative property tells us that the order doesn't matter. We can switch the 3 and 4 around and we should get the same answer because adding real numbers is commutative, right? And let's just double check it here. So 4 plus 3 is going to equal 7. 3 plus 4 is going to equal 7. Yeah, that works. Addition is commutative. Okay, that's what we expect. The associative property tells us that the grouping doesn't matter. We can group the operations in any order we want, in any way we want, and we should get the same answers. So let's try that again. So here on the left side, 4 plus 3 is 7. So 7 plus 2 is going to be 9. And over here, 3 plus 2 is 5. And 4 plus 5 is 9. So once again, as expected, addition is associative. And that's good because these operations, the fact that these properties work means that we can manipulate algebraic expressions. Let's take a look at subtraction here. So we're looking at 4 minus 3. So what's 4 minus 3? That's 1. 3 minus 4 is negative 1. Well, that doesn't work, does it? Okay, so subtraction is not commutative. Let's look at the associative property. 4 minus 3 over here, that's going to be 1 minus 2. 1 minus 2 is going to be negative 1. And on this side, 3 minus 2 is going to be 1, and 4 minus 1 is going to be 3. Well, negative 1 is not the same as 3. So what do we see? Subtraction is not associative. Now, this is actually a problem because that means we can't work with subtraction in the same way as when we can with addition when we're trying to solve equations, when we're trying to do algebra. It would be better if we could. It would be better if subtraction were commutative and associative. So what can we do? Well, we're going to try and rethink subtraction as the addition of a negative, right? Just like we were talking about. So let's think about subtraction as the addition of a negative instead. And I'm going to try and rewrite these equations here with this new concept of subtraction in our head. So instead of 4 minus 3, I'm going to consider this as 4 plus negative 3, right? The addition of a negative. And now, if I want to see if this operation is commutative, I can swap the numbers around. So I'm going to have negative 3 plus 4. Let's see if this works. Okay, so 4 plus negative 3, that's going to be 1. Negative 3 plus 4, that is 1. Look at that. It works. Okay, now we are able to use the commutative property. Let's try the same thing with the associative property. So I'm going to write this down as, well, this first one's fine. I'll leave this as 4. We can say plus a negative 3 if you want. Minus 2. But on the right-hand side, this is where I want to be a little bit careful because here we said 4 minus this entire thing. We're kind of splitting up the negative sign from the 3. We don't want to do that. When we're thinking about subtraction as the addition of a negative number, you need to keep that negative sign attached to that number. Okay, so what we're going to do is over here, we're going to say this is 4 plus, and then in parentheses, negative 3, and then minus 2. Okay, so this is another way we can think about subtraction. What do we get here? Well, let's take a look. 4 minus 3 is 1. 1 minus 2 is negative 1. Okay. Over here we have negative 3 minus 2. That's negative 5. And we have 4 plus a negative 5. Well, that's a negative 1. And look at what we have. Negative 1 is equal to negative 1. So by reimagining subtraction as actually the addition of a negative number, that allows us to actually treat subtraction as addition. Everything's addition. Subtraction doesn't exist. You only have addition of positive or negative numbers. And so then because everything is addition, the commutative and associative properties, they work again, and that allows us to do our algebraic manipulation. All right, so hopefully that was a good review of addition and subtraction. We looked at a few things today. We looked at the idea of an additive identity. That's the number 0, because you can add 0 to any number and you'll get that same number back, right? So there's no change. It's going to be identical. Next, we looked at the idea of negative numbers. So negative numbers we defined as something you add with the original number in order to get 0, to get the additive identity, where a plus negative a is going to give you 0, right? After that, we looked at subtraction, and we saw that it was the inverse operation to addition. Subtraction undoes addition. Addition undoes subtraction. They're inverse operations of each other. And then what we did is we reconceptualized subtraction as actually the addition of a negative number. And we saw that was really useful because that allows us to recover the commutative and associative properties that allow us to do algebra. And so when you're doing algebra, it's often a good idea to think of subtraction as really addition of a negative number. So there's no subtraction. Everything's addition. That way, the commutative and associative properties are going to hold. Okay, so that was good. I'll see you next time, and we're going to take a look at some more properties of negative numbers.